So let's take a look at the average value of a function. Now, given a function f of x and an interval for that function, let's say that interval goes from a to b, we can actually find the average value of the function over that interval. And the average value is written as f, and then below it as a subscript is just average, so f sub average, or the average value of the function. And the formula for that is going to be 1 over b minus a times the integral from a to b of the function itself, so the integral of f of x dx. Now, similar to how there was a mean value theorem for derivatives, there's also a mean value theorem for integrals, and it states that as long as f of x is continuous on the interval from a to b, whatever that interval is, there exists a value c where f of c is going to be equal to the average value. And really all we're doing is setting the function f of x equal to the average value that we find, and all we're going to do is solve for that x value. Now, for this first problem, all we have to do is find the average value of the function on the given interval. So for number 1, we have f of x equals cosine to the fourth times sine of x, and our given interval is from 0 to pi. So realize that 0 is our a value and pi is going to be b. And the interval, remember, goes from a to b. Now let's go ahead and find the average value. So remember, the formula for average value of the function is going to equal 1 over b minus a. So in this case, we have to take pi minus 0, which is pi, times the integral from a to b, so from 0 to pi, of the function itself, f of x, which is equal to cosine of the fourth x times sine of x times dx. And then we can go ahead and evaluate the integral from there. So in order to evaluate this integral, realize that we can do u substitution and make u equal to cosine of x. So if u equals cosine x, then du, or the derivative of cosine x, is negative sine x times dx. So then if we isolate dx, dx equals du over negative sine of x. Now I can go ahead and substitute everything back into the integral. So we get 1 over pi times the integral from 0 to pi of, well, we made cosine of x our u, so we have u to the fourth times sine of x, and then times dx, which once again is equal to du over negative sine of x. Realize that the sine of x's will cancel. A negative 1 can come outside the integral as a constant, so we get negative 1 times 1 over pi, which is just negative 1 over pi, times the integral from 0 to pi of u to the fourth du. Now the integral of u to the fourth is u to the fifth over 5. Don't forget we do have negative 1 over pi outside the integral as a constant. And then now I can go ahead and replace back my u. So if I write up here, we have negative 1 over pi times cosine of x to the fifth power, because remember u is taken to the fifth power, and then divided by 5. And then I'm just going to go ahead and combine the 5 and the pi. So I'll rewrite it as negative 1 over 5 pi times cosine to the fifth x. And now we can go ahead and evaluate from our bounds of 0 to pi. So when we evaluate, we do have negative 1 over 5 pi as a constant, times, now when I plug in pi for x, we have cosine of f, or cosine of pi, which is negative 1. Negative 1 to the fifth is negative 1, minus, when I plug in 0 for x, cosine of 0 is 1, 1 to the fifth is 1. So then we have negative 1 over 5 pi times negative 2. Negatives will cancel, and so our final answer is going to be 2 over 5 pi as the average value of the function over the given interval. Now for number 2 here, we have f of x equals x minus 3 squared, and our interval runs from 2 to 5, so 2 is our a bound, 5 is our b bound. And notice we have an extra part here where we find c such that f of c equals the average value of f. So remember, this is just the mean value theorem for integrals, so we're going to set the original function equal to the average value once we have found it. So let's go ahead and first find the average value similar to the previous problem. So once again, the average value equals 1 over b minus a, so 5 minus 2, which is 3, times the integral from 2 to 5 of our function f of x, which is x minus 3 squared times dx. Now in order to integrate x minus 3 squared, we can just use u substitution. So if u equals x minus 3, du equals 1 times dx. And so we can go ahead and substitute into the integral. So we get the integral, or 1 over 3, times the integral from 2 to 5 of, we made x minus 3 our u, so we have u squared times dx, which dx is just equal to du, so we have u squared du. So then the integral, we have 1/3 as a constant, the integral of u squared is u cubed over 3. So then we have 1 over 9 times u cubed. Now I can go ahead and substitute in back the u. So we have 1 over 9 times x minus 3 cubed. So now I can go ahead and evaluate from the bounds of 2 to 5. Now when I evaluate, we have 1 over 9 as a constant times. When I plug in 5 for x, we have 5 minus 3, which is 2. 2 cubed is 8. Minus, when I plug in 2 for x, 2 minus 3 is negative 1. And negative 1 cubed is also negative 1. Now 8 minus negative 1 would mean 8 plus 1. Now 8 plus 1 is 9. 9 times 1 over 9 just gives us 1. So 1 is going to be our average value. Now for part B, we need to find c such that f of c equals f average. Now remember, the original function given to us was f of x equals x minus 3 squared. So all we have to do is set f of x equal to the average value and then to solve for the x value. So in this case, we're going to set x minus 3 squared equal to our average value, which we just found to be 1. And as mentioned before, all we have to do now is solve for x. So if we go ahead and take the square root of both sides, x minus 3 is going to equal plus or minus the square root of 1, which is plus or minus 1. And then we can add over the 3. So x equals plus or minus 1 plus 3. So in this case, we have two possible x values. So the x value can be negative 1 plus 3, which is 2. Or the x value can be positive 1 plus 3, which is 4. So those are our two x values, or in this case, those are our two c values, such that f of c or f of x equals the average value.